earlier classes we have learned about the few basic things regarding Fortran programming. As for example, the input output statement, that is read write statement, how to write an mathematical expression, how to name a variable, and lastly we have also learned about control statements like if and go to. Today we shall use these concepts to write few simple programs. For example, to find perimeter and area of a circle of radius, area of a circle of given radius. This is our problem. So we know that if r be the radius of a circle, then its perimeter p is equal to 2 pi r and area is pi r square. So we have to write this r will be the input. So we start writing our Fortran program as read star comma star r. This r stands for the radius. R is equal to blank in meter. So what it does, first it reads the value of r, say r is supplied 2.7, then it gives you r is equal to 2.7 in meter. It is. Then we need to calculate pi. So pi, we write pi as a cos inverse minus 1.0, because cos inverse minus 1 is 180 degree, or it is pi, because this result is obtained in radian, as I have stated in correction with library function. So it is the value of pi. Then perimeter p is equal to 2.0 star pi star r, and area A is equal to pi r square. This is star r square. So we write P is equal to blank, the value of P blank in meter, then this hat is used to denote power. So if we write a hat 2, that means a square, so this represents m square. So area is written in meter square, or you can write it meter square. Then this is stop and so this is a very simple program which calculates the area, perimeter and the area of a circle. Similar problem involving geometries is the sphere, cylinder and right circular cone. You may work out these examples of your own. Then I consider another example which involves the coordinate transformation. Say we we have a point in 2D, and the Cartesian components of it, that is x and y, are supplied. We are to find out the corresponding polar coordinates. This is a so xy to r theta. This is our problem. So these are the x and y are provided. We need to know r and theta. We know that r is equal to x square plus y square, the positive square root of it, and tan theta is equal to y by x. This is the transformation law. So first thing is that read x, y, then then we write r is equal to x double star 2 plus y double star 2. While writing exponent, do not put decimal unless it is required. So if you want to write x to the power 3 by 2, then do write x double star 1.5. But if you need to calculate x to the power 4, it is preferable to write x double star 4. And I strongly discourage for writing this one. We prefer to write it in integer mode. So this is the, now if we want to find out tan theta, then the problem is there. Firstly, tan theta is equal to tan inverse y by x, but there is a restriction that x must not be 0. If x happens to be 0, then tan theta is not defined from this relation. So we write if x not equal to 0.0, then theta in radian, because the output is in radian, then this is a tan y by x. Let me explain this line. This line will be executed if and only if this condition is satisfied. When x happens to be 0, this line will not be executed. This is a simplified version of if statement that I have studied in the earlier class. What happens if x is equal to 0? If x is equal to 0, then this is xy coordinate system. Then the point lies on the y-axis, and the value will be pi by 2 if y is positive, and it will be 3 pi by 2. This is pi by 2, and it will be 3 pi by 2 if y is negative. So precaution has to be taken care of. So we need to apply both conditions, x is equal to 0 and y is equal to positive. I am going to take this one. If x equal to 0 and y greater than 0.0, oh, I have not defined pi, so we need to define pi for add-in line. Theta r is equal to pi by 2.0. So let me explain this line. This line imposes two conditions, and the statement will be executed when both of them are satisfied. No or, it is and operation. So this line will be executed when x is equal to 0 and y is greater than 0. Then this is the definition of theta, and if x equal to 0 and y less than 0.0, so we have taken up all those possibility. Only thing that is left is that x is equal to 0, y is equal to 0. That can be taken into consideration by putting this greater than or equal to. Oh no, sorry. Let me keep it like this. And this is the only provision that is left is x is equal to 0, y is equal to 0, then theta is equal to 0. So then if x equal to 0.0 and y equal to 0.0, then so we have defined theta for all the occasions, but there is no such problem with r. Then if we want to find theta in degree, then we write theta d is equal to theta r star pi divided by 180. And finally we write Cartesian coordinates. It will write this thing in total, then the values of x, and then we write two polar coordinates. I have written the output in degree, so we have used theta d, then stop end. The message that I want to convey to you through this program is that although the program seems to be very simple at the beginning, but one should set up the logic in a flawless manner. That is, it should take into consideration all the possibilities. While converting or getting r theta from xy, we generally do not take into consideration all these things. We generally apply this relation. But during computer programming, you need to take special care. Otherwise, if any one of these conditions are satisfied, there will be a problem in this line. So this is the deep thinking required before performing a flawless or bugless computer programming. Then there are similar problems. You may consider transformation from xyz to r theta phi, that is Cartesian to polar, or you may go to rho phi z. These are the simple examples. If we want to, the homework is left that you know r theta, how to get xy. It is a very simple problem. So because x is equal to r cos theta and y is equal to r sin theta. Only thing the care has to be taken regarding the value of theta in radian or in degrees. Another simple example that I am going to consider is the identification of the digits of bits of a two-digit number. That is to say, I have a two-digit number, say number is 71. I need to identify the digit in the unit place. This is in the unit place, and the digit in the 10th place. And the simple application would be to construct the number which is obtained by interchanging the bits in the units in 10th place. So how to do this? First thing, we consider the number to be n. So we read n. Since the program I am going to perform is for a two-digit number, it will fail for a number having 3 or more digits. So first the restriction has to be put. If n is greater than 99, then this program is not applicable for n greater than 99. Then we ask the program to stop and then end if. So if n happens to be greater than 99, the program will stop giving you this message. First thing, how to identify 1. You know the number n is, as for example, 71. If we divide this by n by 10 in integer mode, don't put any 0. So the result will be, actual result will be 7.1, which will be converted to 7. So the result is 7, which is the digit in the 10th place. So we identify the digit in the 10th place. n1 is equal to n by 10. Once you do this, this part can be identified in two ways. One is that if we call it n0, then we can write it n minus n1 into 10. So n1 is 71 and this one is 7 times 10. So n0 is n minus n1 into 10. Now we have identified the digits. So the digits are digits of n1. If you want to construct the number m, which is obtained by interchanging the digits of units and tenth place, that is, if we want to get 17 from 71, then what we do, 10 times n0 plus n1, then write m. I am not going for any augmentation. This process can be continued for other things. Say if you have a 3-digit number, say a 3-digit number 1, 2, 3, then you divide it by by 100, then you will get the unit place. The number in the thousand place. So we write n2 is equal to n by 100 and continue the same process. As the next example, I consider the relation between the angles and sides of a triangle. We know that if we have a triangle ABC, then in general by capital A we mean the angle A, capital B is the angle B, and capital C is the angle C. The side opposite to angle A is denoted by small a, small b, small c. If we are provided with two adjacent sides and the angle in between them, then we can find out every other things regarding the triangle. Say we are supplied with B, A, and capital C. In general, we provide this value, provide the value of the angle in general in radian. So we write it as read. For small a we write SA, for small b I write SB, and for this I write capital C, CC, capital C in degree. So this is value of angle C in degree. So the D is used. First thing is that to define pi. Then the third side we know that c square is equal to a square plus b square minus twice ab cos of c. So small c square is SA double star 2 plus SB double star 2 minus 2.0 star SA star SB star cos of CCD. Think of it. Is there anything wrong? Yes, there is a mistake in the programming, because this angle has been provided in degree. So we first calculate CCR. This is CCD star pi by 180. So the correct statement would be this is CCR, capital C in radian. Then small c is equal to small c2. Then we have found out the third side. So let me again see the problem. A, B, C, A, B, C. This was given, this was given, and this was given. These three were given. This has been calculated. This has been calculated already. Calculated. Now we need to calculate A and B. The A and B can be done in this way. We know that A by sine A is equal to B by sine B is equal to C by sine C. So firstly, all the small sides are known, A, B, C are known. So you can take these two equations and find out the angle A. Say sine of A is equal to A by C, A star sine C by C. Yes. So we can find out capital A in radian is equal to A sine of this thing, is A star sine of CCR by SC. You see, I have written this is small a, this is sine of capital C in radian divided by the small c, and similarly, so SAD is equal to pi, and similarly SBR, and then from SBD we can calculate SBD in a similar way, and you then finally write the inputs and the three outputs that you have calculated. So provided this thing, all the other quantities related to the circle can be evaluated using the proper formula. The thing that I want to remind you, that is the naming of the variable is very important. If you write to D, E, F, then the program will be executed correctly, but whenever one wants to go through the program, then he will face some difficulty in recognizing the things. Here I have written the name in such a way that when anyone who is habituated with this same custom, that angles are denoted by capital letters and the corresponding sides opposite to an angle is denoted by a lowercase number, then it will be easy for him to see what stands for what. Simply this is capital C with R means in radian and D for degrees. Now let me consider another simple example. I cannot remember. Another example, let us consider the evaluation of the area of the triangle, which could be done by the example taken in the earlier class. That is, sorry, in the earlier example, A, B, C, then the area of the triangle is half into base. For base it is small a times this much. If we call take the angle B, then this is sine B is equal to H by this much is C, H by C. So we can write H is equal to C times sine B. So the formula is that if you take the two sides A and C, then it is the sine of the angle in between these two sides. You can apply this formula to find out the area of the triangle that I have considered in the just previous example. Here I am going to calculate the area of a triangle, area of a triangle using the Heron's formula. Where S is equal to A plus B plus C by 2. Now here special precaution has to be taken whether these three sides forms a triangle or not. Otherwise we may lead to a case where any one of these three may go to negative, maybe negative, and the result will be erroneous. So first thing is that we read, since there is no angle involved, we need not to put S. This is sufficient. Here there is no confusion of sides and angles because the triangle has been specified only through its sides. So we are writing A, not SA or capital A. Then provided A, B, C, we must check whether these results are true. That is, such three sides, can they form a triangle or not? That is, we first go for the triangular inequalities, triangular inequalities, which says that A plus B must be greater than C, or B plus C greater than equal to A, and C plus A greater than equal to B. If any one of these three condition fails, then they will not form a triangle. So first we check this. So if A plus B less than C, this is the first condition, or B plus C less than A, or C plus A less than B, then that is, if any one of the three conditions fails, then what will write? Wrong inputs. Stop. So we will be arriving at this line only when the triangular inequalities are satisfied. So we write S semi-perimeter A plus B plus C by 2.0. Then I go to A2, S into S minus A, S minus B, S minus C, and then area is equal to sorry, A2, then write A, B, C and A. Oh, there will be a problem, area, so we write CA, sorry, and write CA and then stop end. Writing the outputs, take special care that you convey the message to the user of the program, the what is what. So they should be augmented properly so that user can identify which is the value of A, which one is the value of second side and third side, and the area of the triangle. These are the few simple examples that I have chosen to make few things clear before going to computer programming. Say if we want, if we supplied with A is equal to 1, B is equal to 2 and C is equal to 4, this result, these three sides do not form a triangle. So if we go to calculation of area using this formula, the quantity within the square root will be negative. So the precaution must be taken so that we do not work with any wrong inputs. So this is the precaution that has been taken. In the next class, I shall introduce the do loops. Do loops are used for repetitive works.